Good afternoon, everyone. I'm Hao Yang from Tsinghua University. This is a joint work by the research group led by Professor Han Duan from Tsinghua. Co-authors are from Virginia Tech, UC Irvine, UT Dallas, Fudan University. This research is about the new promotion service in GitHub. As we all know, GitHub has now become the most important code management and sharing website. Many developers create their own repositories and share their code on it. In addition to being used as a code repository, GitHub also integrates several functionality for online socialization. Developers can watch, start, and fork repositories of others. For example, starting a repository means a developer is interested in this project and the code in this repository can be reused effectively. Due to its prominent role in the software community, the number of stars, watches, and forks attached to a GitHub user or repository has been considered a strong indicator of coding skills, and it is used as a metric when screening job applicants. For example, DevScaler, a developer screening and online interview platform, states that good code is forked and starred a lot, so pay attention to this element. In Zhaopin, the most popular online recruitment service provider in China, many job advertisements related to software development require applicants to have more than a certain number of stars on their own repositories. The most common requirement is to own a repository with at least 100 GitHub stars. With such requirements, some developers attempt to manipulate the social statistics of their own GitHub accounts by purchasing stars and forks. For example, GymHub, which is an online shop selling GitHub watches, forks, and stars. People will pay for the number of stars provided by the accounts controlled by the websites. Since 2018, there have been some reports about such fraudulent activities. Although this promotion service on GitHub is another type of fraud and it is not allowed in most instances, there is no systematic study on this issue, not to mention a deep understanding of the problem scale and fraud strategies. In this research, we made following contribution. First, we performed the first comprehensive study on GitHub promotion and uncovered the traits used by suspicious promoters. Second, we conducted a large-scale measurement on more than 14 million GitHub accounts and identified more than 63,000 suspected promotion accounts. Third, we shed new light on how this promotion service is operated, and also disclosed a hidden functionality of GitHub that allows a user to pretend to be a skillful developer. The left figure shows the architecture of the detection system. We first described the dataset used to understand GitHub promotion. Then we introduced how to conduct the data preprocessing and the data analysis. Later, we present how to train the classifier and the detection result. Finally, we show how we validated this result. The first challenge we meet is how to collect accounts data. We collected the GitHub data from the following three sources. First is GH-archive. It records the public GitHub timeline and archives it for further analysis. We collected all archive files from 2015 to 2019. Second is GitHub API. GH-archive only archives the history since 2016 and also misses the registration and profile information. So GitHub API is utilized to collect this missing data. Third is GitHub web interface. Through the web interface, we can crawl the information directly from GitHub web pages, such as avatar, the popular repository list, and the hot trend list. Finally, we extract more than 23 million accounts. Then we should collect training data to build our classifier. In order to acquire promoter accounts, we contacted 10 promotion service providers in the instance message group and purchased 1,023 star and fork promotions for our test repository. To avoid these providers coming from a single group, we contact 4 from the QQ, 3 from WeChat, the rest 3 from Telegram. For the normal account samples, we consider authentic users who have made major active contributions in well-known repositories. Specifically, we collected two kinds of accounts: the contributors of popular GitHub repositories and those who have proposed valuable issues on popular repositories. The former accounts have a considerable proportion of commit and push events, while the latter have a number of operations like push, issue, and comment events. The table shows an operation sequence in a short interval from a promotion account. The fifth record is the test repository we used in our study. We observed that all operations are start operations, and the interval between two operations is less than 20 seconds. The promotion account performed start operations on not only our test repository, but also other repositories that belong to Facebook, Alibaba for evading detection. According to the observation above, we focus on three characteristics to distinguish the promotion accounts from normal accounts. First, most of the promotion accounts operations are start and fork. By contrast, the operations on normal accounts are much more diverse. Second, promotion accounts are usually associated with a large number of start and fork operations in a short time. Most promotion accounts perform the start and fork operations on well-known repositories in order to disguise as normal accounts for evading detection. To overcome this challenge, we used the time interval of adjacent operation appear as a feature. Finally, we applied the SVM-based classifier on the dataset and detected 63,000 suspected promotion accounts. Due to the lack of ground truth data, it is difficult to validate suspected promotion accounts. Here, we noticed when a repository rising in popularity receives many stars in a short time, it has a long-tail distribution and shrinks slowly. The figure is the time distribution of stars between a normal repository and a suspicious promoted repository. The top is the VS Code repository published by Microsoft. The bottom is related to a suspicious promoted repository identified by us. We can see that in the promoted scenario, there are extraordinary star spikes. On the right side, we can see the star cumulative distribution of these two repositories. The top one linearly increases, while the bottom one has a big jump, followed by an insignificant increase. This indicates that promoted repositories usually experience a drastic increase in the number of stars and forks within a short time. So we randomly sampled 1,000 out of those 63,000 suspected promotion accounts and focused on the repositories that had been starred or forked, and found the accuracy of our method is more than 97%. GitHub provides a functionality that allows accounts to modify a committed message in case the owner has submitted private information. However, we found that promotion service provider can abuse this functionality and forge retroactive commits. The left figure is the origin commit history of our honeypot repository. It had only 2 contributions in 2016. The right figure is modified by forging historical commits from promotion service providers, and it shows that we had 119 contributions in 2016, which can deceive others into thinking that we are productive developers. To forge retroactive commits, one must first change historical records stored separately in 2 local files. Then, one must forge a temporary file and tamper with its content, such as adding and deleting characters. By uploading these files back to GitHub, the promotion service providers can change historical record at will. In our research, we find that some small business, especially IT companies, exploit GitHub to promote their business. A company can publish the repository on GitHub and place a link to their homepage on GitHub. By exploiting GitHub's web ranking, their links are also promoted, similar to Black Hat SEO. In this figure, the company first publishes the repository on GitHub and places the link in their source code. In most cases, the source code they published on GitHub is a free trial version that provides only limited service, specifically supporting only few users with restricted functionality. We suggest that GitHub should take action to define the existing promotion. One possible action is to send emails with confirmed information to suspected accounts and ask them for active response. Another action could be requiring suspected promotion accounts to complete a more complicated captcha during registering. They indicated that they would pass our request on to the right team for redemonition. In summary, we have conducted the first comprehensive investigation on a new promotion service on GitHub called Promotion-as-a-Service, which helps developers increase the number of stars and forks on our repository. Then, we have developed a behavior pattern model by purchasing service from actual GitHub promotion service providers and have detected more than 16,3 suspected promotion accounts. We believe that our funding will help the security community to pay more attention to all kinds of fraudulent promotion methods. That's all. Thank you for your listening.